Hello friends, welcome to NPTEL online certification course on soil and water conservation engineering. I am Rajendra Singh, Professor Agriculture and Food Engineering Department, IIT Kharagpur. And we are starting week 3 today, that is lecture 11, and the topic today is introduction of bunds. Just to give you an idea about the course content that we will be covering in this week, this particular week lecture 11 we will introduce bunds. In lecture 12 we will go for contour bunds, that is we will see the theory behind contour bunds, what is their applicability, where they are built, what is their adaptability and what are the design features. And then in lecture 13 we will use those concepts to solve certain problems dealing with design of contour bunds, that is what how to design various the cross section or various other parameters related to contour bunds. Lecture 14 will be on graded bunds, where we will be seeing the adaptability, the theory behind design of graded bunds. And then in lecture 15 we will handle the problems on design of graded bunds using the concepts which we will learn into lecture number 14. To start with the bunds, bunds are basically small embankments, embankment type structures constructed across the slope of the land either with soil or stone. So, they are important components are they are small embankment type structures, that means simply kind of embankment or dam what you see, that is some kind of cross section like this or whatever be the section, this is how they will look like, and they are constructed across the slope of the land. That is very important. You remember that in all previous classes we discussed that most of the soil conservation measures we take or adopt is across the slope, not along the slope, that is the regions also we know. So, if the land slope is in this direction as shown in this picture, then obviously our bunds will be constructed across the slope in this direction. So, that is how you see this is a bund, this is a bund line and this is another bund line. So, it is always taken across the slope, that is this is the slope along the length of the field and this is across the slope. And the material of construction is soil or stone. So, that is the material which is readily available in the nearby positions, that is it could be soil which is preferred because the cost economy is a major constraint, or if soil is not of good quality, soil is not available, then we bring stones also to build this cross section. As I mentioned that cross section could be trapezoidal or just a semicircular kind of thing. And these bunds are popular soil and water conservation measures because of their ease of which the advantages we will see little later, but just at this point of time I must tell you that because of the ease of construction, ease of maintenance, because of the economics, that is there because they are inexpensive, because they can be built using the locally available soil or stone. So, that is why these are one of the very popular soil and water conservation measures adopted in field conditions. Now, coming to functions of bunds, the functions are, that is they are built to prevent soil erosion, to collect surface runoff, to increase water infiltration and to prevent gully formation. As we have already seen, we have seen that this is the typical cross section which we have seen. It is a trapezoidal kind of cross section which is shown in this picture. So, these are this is the slope direction and this construction is done across the slope in this direction, and the same thing is shown in here in this picture. So, as you can see that this is one line of bund and this is another line of bund. So, because of this kind of shape which is constructed here, then what happens that whatever rainfall occurs over this area, that gets collected within these two bunds, which is this within this area itself. So, as if you remember, when we discussed the soil erosion, we saw the types of erosion, that is the first water erosion process is raindrop splash erosion, that whenever rainfall occurs, because of the impact of the kinetic energy impact, the splash takes place, that means detachment takes place. And then next is detachment. If you remember the processes, this is detachment, then transportation and deposition. These are the three processes. The second process is transportation, and for transportation we saw that is the overland flow which causes the transportation. And here what we are doing is that we are storing the water, whatever water is falling within this area, that is rainfall is occurring over there, this area, we are storing that, we are not allowing that to flow beyond this bund structure. Same is true, whatever rainfall will occur here, that will be stored between this and this bund. So, that is how what we are doing is that we are basically preventing the flow of water, and that is how this function comes, that is to collect the surface runoff. So, surface runoff gets collected between the two bunds, whatever rainfall occurs, that gets collected, that surface runoff that gets collected. And because we are checking the flow of water, that simply means when because we are checking the overland flow process itself, that means there is no chance of occurrence of sheet erosion. And once sheet erosion does not take place, obviously there will be no soil transportation, that means there will be no soil erosion, and that is how the bunds prevent soil erosion. Now, the other function, increase the water infiltration. Now, when you have seen that whatever rainfall occurs, that will get stored in between these two bund sections, and if that happens, that means water is standing there for longer period of time. So, enough time is available with the water to infiltrate into the soil. So, that means there will be increase in the total infiltration that would have taken otherwise when the flow was allowed to take place. And also you remember the next function is the prevention of gully formation. You remember we said that there will be sheet erosion which results in rill erosion, which if continues results in gully formation or gully erosion, that is these are the various types of erosion. So, once we are checking the sheet erosion itself, there is no question of rill erosion and no question of gully erosion or gully formation. So, this is how by simply storing whatever rainfall occurs in between these stones within this particular area, which is which is enclosed by two bunds, neighboring bunds, we are ensuring that various functions of bunds are taken care of, that is prevent soil erosion, collection of surface runoff, increase in the water infiltration and prevention of the gully formation. So, all these functions take place. Coming to suitable conditions for bunding. If you consider the suitable conditions of bunding, then these are preferred in low rainfall areas, because as you can see that whatever rainfall occurs, we try to store that in between two bund areas. So, if it is a very high rainfall area, that means either the cross section has to be too big, that means the cost will be a factor, or and also too much of land will be required for constructing these bunds. So, that is why they are always preferred in low rainfall areas, and also the land slope has to be within 2 to 6% slope. So, these are the two limiting cases, that is they are preferred, bunding is preferred in low rainfall areas and for land slopes which are limited to 2 to 6%. And then red clay soils and mixed soils are suitable for constructing bund. As we saw that we simply build a trapezoidal section, that is the most preferred section. So, obviously, that is because we simply use the soil to create this. So, obviously, from the stability point of view, we have to see the soil should have soil should be stable, and that is why red clay soils or mixed soils are preferred. Generally, typically just pure sand will not be preferred, because stability will not be there. So, from stability point of view, red clay soils and mixed soils are the preferred one for constructing bunds. These are the from the suitability point of view. Then coming to advantages of bunds, some of the functions we have already seen. So, advantages are related to that. They are effective in storing surface runoff and preventing soil erosion. We have already seen in great detail that in between two bund sections, the surface runoff, whatever rainfall is occurring, that gets stored, and obviously because the flow of water is not taking place. So, the soil transportation is not taking place, that means soil erosion is prevented. They are relatively simple and cheap implementation, as we have seen that the material of construction is soil or stone, which is readily available in the field condition, and because a very simple shape, say trapezoidal shape is provided. So, they are very simple to construct basically, and obviously because the material of construction is readily available, I mean we prefer readily available material of construction. So, generally it is quite economical in construction. Simply also because of the simple construction, they are easy to maintain also, because this is just a trapezoidal cross section. So, if any little bit of erosion takes place, we can always fill the soils, which is again readily available in the nearby area to maintain the shape of the bund. So, the maintenance is very easy, and they are applicable to fields that are already under cultivation. So, basically they are used also for the land which is for cultivable lands of course, and they can be adopted in areas which are under cultivation, and it results in effective utilization of nutrients and fertilizers, as these are not washed away. So, we have already seen that when bunds are constructed, and whatever rainfall occurs, that gets stored in this area, and this very area will be used for cultivation also. This area is also used for cultivation. So, obviously, whatever nutrients or fertilizers we apply here, because the flow of water is not there. So, obviously, whatever application we make, that will be readily available to the crops, and obviously, they are not washed away because flow is not allowed to take place from this area. So, this is these are some of the advantages of the bunds. But as we know that along with advantages, there are also some associated disadvantages also, and one major disadvantage of the bunds is loss of cultivable land. So, obviously, if you have a certain area available for agriculture, which has a slope in this direction, and if you want to build a bund here, which has a typical cross section, already we have seen that the cross section typically preferred is trapezoidal. So, obviously, the base area, that is equivalent to the base area along this length, is really that is not available for cultivation. So, that means it results in loss of cultivable area, and as there are series of bunds in a given area. So, obviously, it results in a considerable amount of loss of cultivable area. So, that is a major disadvantage, and then they also interfere with the farm operations. So, because if the flow is large, which if you want to handle large flow, then obviously, the cross section of this bund will be much larger in section, and in that case they might interfere with the farm operations. Of course, while designing we try to see that the farm operations are not affected, but sometimes it becomes inevitable. Then contour bunds need an even ground, otherwise water will collect in lower spots, which may cause mosquito breeding. So, obviously, as we see that initially when we design these, we always say that water should get stored in this area, and of course, with time this water will be infiltrated or will be carried away depending upon the function of the bund. But if there are some low lying area here in between these two bunds, so obviously, water will be standing there, or more water will get collected here and will be standing there for longer period of time. So, that might result in waterborne diseases, especially it might result in mosquito breeding. So, that is why we must see that there are no potholes in between the bunds or the area, there are no storage possibility of water over longer period of time, that we have to ensure. Then for stone bunds, construction cost may be higher, which is quite obvious. The alternate material we have seen, that is soil, which is readily available in the field, and then we allow that soil or rather they use that soil which is available for constructing the bunds. But in case soil is not suitable, then obviously we have to go for stone as material of construction, and in that case a stone has to be brought, maybe it has to be purchased. So, that is why the construction cost will definitely will be higher in this case compared to what would have been if the soil, good quality soil is available in the area. Then temporary water logging problem may be faced in heavy clay soils, which is quite obvious because we are allowing water to stay here for longer period of time, assuming that most of this water will get infiltrated. But if it is a heavy clay soil which has a infiltration rate is very low, then obviously water will not get infiltrate, and that means water will be standing there for longer period of time, which might result in water logging problems or may affect the crop production in that particular area. So, that is why we have to be careful when in what kind of soils we are constructing the bunds. So, this is a matter of concern and we have to be careful about that. Then we come to the types of bunds. Now, coming to types of bunds, bunds are of based on the functional requirements. Bunds could be of two types, that is contour bunds which are used for storage of water, and graded bunds which are primarily used for safe disposal of excess water. So, two category of bunds are used. Similar kind of structure, we will go into details of these in the following lectures. So, when we say contour bund, it is basically meant for storing water for long period of time. When we say graded bund, they are for safe disposal of excess water. Of course, the cross section remains similar cross section is used in both cases, only little bit of changes take place, which we will see in detail when we go further in the next lectures of this week. Coming to adaptability of these two particular types of bunds, if you consider contour bund, then typically we adopt them for low rainfall areas, we have all seen, and the magnitude here is less than 700 millimeters. So, this is a annual rainfall. So, if annual rainfall is less than 700 millimeters, this is annual rainfall we are talking about. So, annual rainfall is less than 700 millimeters, then we go for contour bunding. Also, the land slope has to be less than 8%. We saw that typically they are adopted for 2 to 6%, but in any case land slope should be less than 8%. And soil should be shallow and light in the sense that infiltration capacity will be capacity should be little bit higher. So, that infiltration and groundwater recharge takes place and water logging problem is not faced, because water is allowed to store for longer period of time. On the other hand, if we consider the graded bunding, where the function is safe disposal of water from the area, then we have two cases. One is that when the rainfall is greater than 700 millimeters annual rainfall, in that case land slope conditions remains the same, that it should be less than 8%, but also in this case it should be shallow and light. So, if shallow and light less than 8%, rainfall is greater than 700 mm, then we go for graded bunding, because we do not want water to stand, we want safe disposal of water. If it is less than 700, then we go for contour bunding under similar conditions. But if the land slope is less than 8%, rainfall is less than 700 mm and the soil is heavy clay where infiltration is very low, we saw that in case of contour bunding, if very clay soil is there, the infiltration, if infiltration is not taking place, then water logging may happen. So, in that case we go for graded bunds. So, these are the conditions that slope in any case for bunding should be less than 8%, rainfall should be less than 700, and if shallow and light soil, then we go for contour bunding. If it is less than 700%, but heavy soil, we go for graded bunding. If greater than 700, even for shallow and light soil, we go for graded bunding. So, these are the adaptability conditions for two major types of bunds which are available, which we will see in the next few lectures also. Then there are some other types of bunds, associated bunds also. For example, Sideburns. These Sideburns are constructed along the slope at the two sides of contour bund. So, this is across the slope and along the slope, just on the side of the contour bund, we construct these bunds which are referred to as side bunds, because they are built on the side. Then another category is lateral bunds, which are constructed along the slope in between two side bunds for preventing the concentration of water on a particular side. So, basically as you can see here, if you just join together all the side bunds all along the length of the field, then it is referred to as lateral bund. And obviously, the idea is that no water should be allowed to flow in this direction. There is no flow of water will be possible, because there is a bund here. So, if you want to check flow of water in this direction, we construct these lateral bunds on this side. Another type of bund is semicircular bund, and it is the name itself suggests they are semicircular shape or half moon design, and they are well suited for planting individual trees. So, as you can see here, this is how they look like. So, they are semicircular or half moon shape or half moon design they are built, and then mounds are built here and trees are planted here. So, for planting individual trees, and each bund, because of their typical shape, each bund has to be made singularly by hand, making them time consuming in implementation, which is quite obvious. As you can see that if you have if all these has to be built individually by hand. So, obviously, the time required and the labor requirement will be much higher in this case. And semicircular bunds can also be applied to steeper slope, because they have their own catchment and the shape, typical shape, which can store water behind the bund. So, even on steeper slopes they can be preferred as compared to the contour or graded bunds which we have seen earlier. Then coming to the design criteria for bunds, there are certain design criteria which we must always remember, like one is the allowable submergence of land. Since the area of land submerged due to ponding affects crops, the level of waste wear and the amount of land to be submerged should be carefully chosen. So, obviously, we should allow only limited area to get submerged under different conditions. For example, if we have paddy which requires ponding water, that is it requires ponding water on the field in general, then the bund dimensions should be such that no runoff is permitted. So, that means, we would like to store most of the water in between bunds, so that standing water is there to sustain the paddy crop or to meet the paddy crop requirement. But if paddy is not the crop, we are going for some other crop, then obviously, which may not require ponding water, then height of waste wear should be designed in such a way that bunds store just sufficient water to meet the requirement of the crops. So, what is done basically when we construct these bunds in the field. So, here what we will do, we will provide some kind of weir here, over which if excess water is there, that overflows and goes to the neighboring one. So, obviously, the flow is allowed, but in a controlled fashion. So, that's to allow, just to see that not enough water is standing here to affect the crop production. So, that is how the submergence is important criteria while designing these bunds. Then economy is construction, which is obvious that the cost of bunding should be kept at minimum, which is obviously not only true for bunding, but for any measures, that the cost is always a major criteria. And here important thing is that cost should include expenses on earthwork and the value of land lost permanently due to bunds. So, this is important, that not only the cost involved in earthwork while for building the or constructing the bunds, that should be taken into account, but also the land lost permanently due to bund, that also makes a component, cost component, which should be taken into account while calculating the total cost of any kind of bunding structures. Then another very important design criteria for bunds is the seepage consideration. Typically, what happens is that when we have this kind of design, so obviously, as we allow water to stand on the behind the upstream side of this dam. So, once the standing water is there and once the material of construction is soil, then obviously some seepage will take place over this. So, this is basically referred to as seepage phase. If you have read little bit of soil mechanics, probably you already know in case of earthen dams we handle this, that there is a seepage phase through which seepage takes place, and that obviously this because it is a standing water. So, seepage will continue and water will go further and further the seepage water, and it will wet the entire cross section, and this top phreatic line is referred to as the seepage line. And in that case what is done is what is important is that as a thumb rule, the seepage line must pass through the base of the bund. So, we design in such a way that this seepage line should never cross the downstream section, because if that happens then this toe becomes susceptible to failure. So, that is why we always see that the seepage line crosses through the base of the bund, and basically the seepage is affected mainly by head of water, the side slope of the bund, and the permeability of the soil. So, this head, the material of construction, and this side slope, that determines the seepage through the structure. Then another important criteria is the non-erosive velocity. The velocity basically is calculated using Manning's equation, which we know already, 1 by n r to the power 2 by 3 s to the power half, and this is hydraulic radius, this is the bed slope, n is the Manning's roughness coefficient, and typical value of 0.04 of this n is used for calculating the flow velocity. And the important thing is that the result built in velocity should be non-erosive, and the upper limits of non-erosive velocity are for sandy soil it should be less than 0.5 meter per second, and for erosion resident soil, even for clay, it should be less than 0.65 meter per second. So, wherever we have to calculate the flow velocity, we use Manning's equation, and then we have to ensure that the velocity is within the non-erosive limits, that should be ensured. Then just to give you an idea about the two types of bunds we talked about, that is contour bund and graded bund, which we will discuss in great detail later on. So, basically contour bund involves construction of narrow based trapezoidal bunds on contours for impounding runoff water behind them, so that it could gradually infiltrate into the soil. So, these are the important, the underlying points are important. So, these are narrow based trapezoidal bunds. So, basically the cross section is trapezoidal, that we are saying, and narrow base. So, we should design in such a way that the base width should be as less as possible, because we already saw that when we construct these bunds, it results in the loss of cultivable land. So, obviously, if the base could be limited to a certain extent, then the loss of soil land, fertile land, cultivable land can be minimized. So, that we have to take into account, and these are built on contours. So, that is why the name contour bund. So, they are always constructed following the contours, contour lines in a field. So, that is why I refer to as contour bund, and function is impounding water, runoff water behind them. So, obviously, when this is there, this constructed water. So, whatever flow, whatever rainfall occurs, that gets stored or gets impounded behind the dam, and obviously, when it is allowed to stay there for longer time, so it gets infiltrated into the soil. They are generally recommended for low rainfall areas receiving less than 700 mm rainfall, which we have already seen in adaptability, and usually constructed on lands having 2 to 6% slopes, that also we have seen already. In any case, slope should not be more than 8%. And the functions are the advantages, whatever we say, we have already seen. Series of such ones divide the area into strips, which we have already seen, check the flow of water, reduce the amount and velocity of runoff, they check erosion, they enhance infiltration and improve groundwater recharge. So, very similar, already we have discussed the functions of bunds, and these functions of contour bunds also are more or less in similar lines. Then graded bunds, these are small embankments that are laid out across the land slope. not along the contours. Important thing is that they do not follow contours, that is the graded bunds do not follow contours in agricultural fields. The entire spacing between two consecutive bunds acts as a channel, where a longitudinal slope along the bund is provided for letting the runoff out safely from the channel. So, basically what happens, suppose if this is the kind of cross section, and if we build two lines. So, this portion what we are saying is this portion between these, that acts as channel, because you remember the function of graded bund is safe disposal of water. So, this entire thing acts as a channel, and a slope is provided perpendicular to the board. We provide a slope, longitudinal slope when we are talking about, that is perpendicular board is provided, so that runoff water is taken safely out of at a non-erosive velocity. And these are preferred in the areas where land is susceptible to water erosion, soil is less permeable, and water logging problems are there. So, obviously, soil is less permeable. So, that means, if it stands for longer period of time, infiltration will not take place and water logging will take place, and that is why we go for graded bunds, and primarily designed to dispose excess runoff safely from agricultural land. So, that is the main function. So, major difference between contour bund and graded bunds is that contour bunds are constructed for water conservation, where graded bunds are meant for disposal of excess runoff. So, that you should always remember, contour bunds water conservation, graded bund disposal of excess runoff. And these are typically constructed in high rainfall areas having more than 700 mm of rainfall, and where excess water has to be removed safely to avoid water stagnation. Land slope is 2 to 8%, maximum 8% we have already seen, and if the soil is deep black soil or less permeable, then they can also be used for rainfalls, lesser rainfalls or rainfall less than 700%, which we have already seen in adaptability table. And this typically, for example, in Bellary region of Karnataka, where soils are deep black soils, we go for graded bund even though the rainfall is less than 700 millimeters. So, thus we have seen what are bunds, what are the types of bunds, what are the functions, what are their advantages, and then we also saw, based on functional requirements, there are two major types of bunds, contour bunds and graded bunds. And in future classes in this week, we will go through the details of these contour and graded bunds and see how to design them by using the principles of design. Thank you very much.